This is Algebra 2, Unit 7, Lesson 3 on vertical stretching of functions. Now, we have seen how to shift and reflect functions using parabolas. In this lesson, we'll also see how to stretch or compress a function in the vertical direction. We kind of think of that as, think of like a rubber band. If you pull the bottom of a rubber band and stretch it, that's basically what we're going to be doing in a vertical direction. So the first exercise will illustrate this concept with three related parabolas. All right, consider the quadratic function f of x equals x squared minus 4x minus 5. The quadratic functions g and h are defined by the formulas g of x equals 2f of x and h of x equals 1/2 f of x. All right, so if I wanted to determine a formula for both g and h in simplest trinomial form, all right, if I look at g right here, it says 2f of x. Well, basically, you're taking f of x and multiplying it by 2. So g of x will equal 2 times x squared minus 4x minus 5. So that's going to be 2x squared minus 8x minus 10. Same idea for h of x. It's 1/2 f of x, so it's 1/2 of this function. So h of x will equal 1/2 times x squared minus 4x minus 5, which is 1/2 x squared minus 2x minus 5 over 2, or 2.5. Either one would be fine. Okay, so now that I know what the functions are, let's sketch each one on our calculator. So the first thing I want to do when I get my calculator out is update my window. So for my window on this, my x values were going from -3 to 7, -3 to 7, and my y's, so -3 to 7 for the x's, my y's are going from -20 to +20. So my y's are going to be from -20 to +20. Okay, so there's my window. Now I want to go to y equals. All right, I want to put in my original function. My original function is x squared minus 4x minus 5. I'm going to put it in the blue one. So it's going to be x squared minus 4x minus 5. The second one was when I multiplied by 2, so that's going to be 2x squared minus 8x minus 10. And then the black one will be 1/2 x squared minus 2x minus 5 over 2. Okay, so the blue one is the original function. The red one is the multiplied by 2, and the black one is the multiplied by 1/2. So what I'm going to do is I'm going to shut the black and the red one off for a minute. So I'm just going to scroll back here to the equal sign. Whoops. And press enter, and that'll shut it off for right now. And then the same thing for this, I'm just going to shut it off. So the one that's going to go first is the blue one. So let's go ahead and graph that so we know what it looks like. All right, so on our graph, we have the function looks something like this. So if I go back here, I'll even do it in blue so you can see it. All right, you can see that it's going to intersect at 1 here and 1, 2, 3, 4, 5 there. So when I draw my blue one, it's going to go something like 2, 3, 4, 5. It's going to go something like that. So that one is the original function, f of x equals x squared minus 4x minus 5. Okay, so now I'm going to do the g of x, which is the red one. So I'm going back to y equals, and I'm going to arrow down here, and I'm going to turn the red one on by turning the equal sign back on, and I'm going to graph that. Okay, so you can see what it looks like there. It kind of squeezed together a little bit. So it came together like this. It went lower, but it's still squeezed together, and it still has the same intercepts. So when I graph this, I'm going to do it in red so you can see it looks like what's on the paper. It's going to go down like this. It's going to go lower, but it's still going to go through the same intercepts. You get the idea. So this is g of x, and that was 2x squared minus 8x minus 10. So that got narrower. So it's like if we grabbed the bottom of the parabola and pulled it down, pretty much. Okay, now let's turn on h of x. So I'm going to go to y equals. I'm going to arrow down to my equal sign and turn it on, so I'm going to press enter. So now when I graph it, the black one, you can see it got a lot flatter, and it still has the same intercepts, it's just going to be narrower. So or flatter, I should say, wider. So I'm going to use my black, so it's going to look like it's on the calculator. It's going to go down like this. It's going to be a lot flatter, but it's still going to go through here. It looks a lot better on the calculator than I can draw it, but you get the idea. So h of x is equal to 1/2 x squared minus 2x minus 5/2. Okay, so using the minimum kinematic calculator, determine the minimum value for each function. Okay, so the minimum, I'm going to do the blue function first. So second trace key, I'm going to use the minimum for number 3. I'm going to do the blue one first. All right, so left bound, I'm just going to move to the right and left a little bit. Enter. To the other side. Enter. Enter one more time. It's at 2, -9. Okay, so F min is at 2, -9. So that one is going to be the blue one, which was F min is going to be at -9. Okay, whoops. So this is at 2, -9. All right, so that's actually the point 2, -9. Okay, now let's look at the next one, the red one. Second, calculate the minimum for number 3. All right, I'm going to arrow down here. I want to do the minimum for the red one, so I'm going to left a little bit, enter, go to the right a little bit, enter, and my minimum is now at 2, -18. So G min is at -18. So that's actually the point 2, -18. Okay, so this point right here is 2, -18. Now for my third one, H min. H min, I'm going to go to my calculator. Second trace key, I'm going to pick the minimum, number 3. I'm going to arrow up, so I get to the black one, and I'm going to go to the left and right a little bit. So to the left a little bit, enter. To the right a little bit, enter. And I get 2, this will round up to 2, -4.5. Okay, so the black one is going to be -4.5, which is actually the point 2, -4.5. Okay, so what have we noticed, if this is my minimum, 2, -4.5, what points did not vary when f was vertically dilated? Okay, so what didn't change? Well, these 2 points right here, this one and this one, the x-intercepts. The x-intercepts didn't change. Now, why didn't they change? Well, if we think about it for a second, when we multiply by the y, because we're multiplying by 2 and 1/2 here, when we multiplied a y value by 0, y equals 0 value, because if in this point right here, the y value is going to equal 0. It's still going to be 0. Okay, so at this point right here, this is the point 2, 0. If we multiply it by 2, it's still going to be something 0 because it's on the x-axis. Same thing with right here. So if I take my point there and multiply it, it's still going to be the same because when you multiply by something by 0, it's still going to be 0. So notice what happened. When we multiplied by a whole number by 2, from the original parabola blue here, it became the red one, so it got narrower. Now, because like I said, you're kind of imagining that you're grabbing it from the bottom and pulling like a rubber band. So if your factor that you're multiplying by is a whole number, it's going to be what's called a vertical stretch. If you're multiplying by a fraction, look what happened to the graph. It got flatter. That's as if you took it and pushed down on it. If you took the blue one and pushed down on it and flattened it out, it got wider. So when we were talking about that is called a vertical compression. So with the vertical dilation of function, if you have h of x equals k times f of x, it is a stretch if k is greater than 1. If it's a whole number, then it will be a vertical stretch. It will be a vertical compression if the function, or if the k is between 0 and 1, if it's a fraction. So with a whole number, it will be a stretch, it will narrow, and when it's a fraction, it will widen. That seems kind of counterintuitive, but that's what happens. You kind of think of it as stretching horizontally and compressing horizontally when you do that. So if the point negative 3, 12 lies in the graph of function y equals f of x, which of the following points must lie on the graph of y equals 3f of x? So we are multiplying by 3. So what is being multiplied by 3 is the y. So if we start with the point negative 3, 12, it's still going to be negative 3 for the x value, but we're going to dilate it by multiplying the y by 3. So if I take 12 and multiply it by 3, we are going to get the point negative 3, 36. So that point will be on the graph. So that's number 2. This is a vertical stretch. So if you stretch this function, the y value we multiplied by 3. Okay. Now we can combine the different transformations together, the stretch and the shift as well. The graph of y equals f of x is shown below. Consider the function y equals g of x defined by g of x equals 2 times f of x minus 3. So, what transformations have occurred to the graph of f in order to produce the graph of g? Specify both the transformations in their order. So to get g of x, I took 2f of x minus 3. Well, what happened first? Well, that would be the 2. Well, that means it's going to be a vertical stretch because it is greater than 0. So it's vertical stretch by a factor of 2. Okay, so it's a vertical stretch by a factor of 2. Then, what does minus 3 mean? Well, it's going to shift, if it's just minus 3, down 3, because it's on the outside of the function. So that's going to going up and down, so this is minus 3, it's going to be minus 3. Okay, so let's see if we can figure out where our point's going to go. So if I take this point right here that is on f, and I want to see where that's going to go, that is the point 2, 1 on that function. So the first thing that we want to do is we want to get g of that value. It's going to be 2 times f of 2 and then minus 3. Okay, so f of 2, when x is 2, y is going to be 1. Well, that should be g of 2, sorry. Okay, and so that's 2 times 1 minus 3 is 2 minus 3 is negative 1. So my new point is going to be at x equals 2, y is equal to negative 1. All right, let's try another one. This point right here is going to be at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is 5, 5. So g of 5, it's going to be 2 times f of 5 minus 3. F of 5 is going to be 5 minus 3. 2 times 5 is 10, minus 3 is 7. So the point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7 is going to be right there. Okay, so see if you can figure out the other 2 points, and we'll draw the rest of this in class next day.